Start it up. All right, can everybody hear me all right? Make sure that first thing.
We can.
I can hear you.
All right, perfect. So welcome everybody. My name's John Ruzick. I was given a high-level 10,000-foot view of a experiment, they call it, that Microsoft is running, called Project Tye. Now, the title of this is a little odd. When Mark was asking me to put this together, he said, give us a snazzy title, and I'm terrible with coming up with branding things, so I threw this out, and 10 minutes later, all of a sudden, this is the Meetup title of this event. So I scream, you scream, we all scream for microservices. Simplified microservice development in .NET with Microsoft Project Tye. Very short and sweet title. So just real quick about me, if you're external, if you're internal to Improving, you probably have met me, I hope. Senior consultant at Improving Atlanta, been there 5.5 years. Just some past projects that I've worked on are some desktop application, WPF, data integrations, BizTalk integrations, JavaScript, Angular web dev, and most recently, microservice architecture with some clients making the jump from monoliths to microservice platform. So kind of all over the map and technologies at Improving. Some passion projects of mine, KegBot, which is a KegBot or kegerator monitoring application. Do some 3D printing, so created a Alexa plugin for a 3D printer, and then a Xamarin Apple Watch golf tips thing that I threw together. So just a little bit of background from where we're coming from on this. So let's talk high level. What is a microservices architecture? And it's really boils down to two things. So an architecture that separates the application into discrete services that each serve a specific business function. And you really compare this to the other side of the coin, the monolithic application, where it's one huge application. All of the services are in one app. And in the microservices architecture, these services then are loosely coupled and communicate via APIs or an asynchronous messaging pattern, as opposed to tied together with method calls in the same application deployment. So just some microservice architectures in use today. I'm sure you've heard all about these. Netflix is probably the biggest and most complex one and famous, just with how they're able to stream and service millions of customers, billions of minutes and hours of content every single day, every single year. So being able to scale that load with this microservice architecture has enabled them to be as successful as they are. A company you might not think of as being cutting edge, but Walmart has actually embraced microservices and transitioned a lot of their applications to a microservices architecture. They're accelerating their deployment and development from everything that you can think of from their mobile app, but also to IoT implementations. And then Uber, this was pretty interesting, I guess, when they first started, they had 2 monolithic apps that ran everything. And they've transitioned that now to an architecture that has over 2,200 microservices running all of the services that they offer today, from your traditional ride sharing to now Uber Eats, Uber Freight. I think they had Uber Helicopter at one point in New York City. So with leveraging that microservice architecture, they've been able to scale up and manage all of these different services. We'll share out this presentation after it's over. I've dropped some source links. The Uber one is pretty interesting if you're into this type of stuff and architecture, and I hope you are because you're here today. It's a very interesting article about how they're implementing it and solving some of the challenges that come with microservices. So a high-level overview of just a diagram of what this usually looks like in a microservice architecture is your services are completely separate. So your identity service, your inventory service, for example, ordering service, customer info service. And each service ideally has its own database. It owns its own entities and is responsible for its own data. There's a couple reasons, and we'll talk about that. There's a couple benefits with this as well. You'll notice that with the application being split into these services, you can actually write them in different languages. So you might have your identity server and inventory services .NET Core, but your ordering is in Node.js. Customer info service might be in Python, and they can have different backend databases. So if your customer info is Mongo, whereas your others leverage SQL Server Relational DB. On the backend, they communicate via a message bus or service bus or event bus, whatever you want to call it, that allows out-of-band communication between services asynchronously. And this also allows for the situation where one of these services could potentially be down, but if you've got transactions that only hit the inventory service and don't need any customer info or something along that nature, you can still have successful transactions processing, even with the customer info service down. Messages can be queued up in your bus, and then when the customer service comes back online, it picks up those messages, can sync up, and everything keeps working. In some cases, that might not be. You might have intra-service, more hard links. Those can communicate via API calls. But the idea is they are in separate deployable units that can be independently scaled and deployed and independently developed. Sitting over here, what this also allows you is if you put an API gateway in front of this, it allows mobile applications or a web user through some web application to all just plug in and then leverage these services. You don't have to develop specialized infrastructure or services to host a mobile app or a web application. They can be reused across whatever front-end deployment that you want to provide to an end user. So what does a typical microservices stack look like? I know I'm involved with this heavily right now, doing some of the projects that I'm doing. So it kind of starts off here in the bottom right, your application code. Got Python, .NET Core, Node.js, an Angular SPA application. Be any type of different code that you're writing for this application. And then the idea is you package that into containers. Docker is by far the most popular. There are other technologies out there, but package those up into Docker containers and then push those containers to a container registry. And then if you're leveraging Kubernetes as your container orchestrator, a lot of times you push and create Helm charts, and then you push that eventually to the Kubernetes cluster that has multiple nodes and an ingress controller to help get direct traffic into your backend services. And not only that, but you've got all of your application code that you've written, but you've got dependencies out there. So Microsoft SQL Server, MongoDB, PostgreSQL, your messaging infrastructure, Azure Event Hubs, RabbitMQ, Apache Kafka, and then some caching, Redis or Memcached. So all of these other dependencies. So a microservice application can get pretty complex with not only trying to match up your code, but with third-party dependencies as well. And then once you get all that working, getting it deployed. So I mentioned some of these before. What are the main benefits of this microservice architecture? So these services can be independently built, and another big bonus is tested. So if I need to make a change or there's a bug, if designed correctly, your QA teams may only need to test one service versus trying to test a regression in the entire application, because we can define that these code changes only impacted one specific service. Written in different languages, I mentioned that. Independently deployed and scaled, right? So in a typical microservice architecture, if you need to horizontally scale that application due to load, you've got to spin up another infrastructure and spin up an entire instance of that application. In a microservice architecture, you can independently scale the ordering service, for example, around the holidays. If that's the thing that's going to get hammered, you can scale that out versus also having to scale out some of the other services, like a user profile service that someone might not be using as often. Your database platforms can be selected based on individual service performance and functionality requirements. In some cases, a service might benefit from a NoSQL database versus a relational database, and you've got the freedom to choose those and tie those in with your services. You're tied into one huge database or one database technology for this application. And containerized applications are OS and platform agnostic. I know right now we're developing in .NET Core, containerizing them into Docker containers, and deploying them to Linux servers. So if you've got your Linux containers set up, you can run them on anything that will run your container engine. So Kubernetes running on Linux, Docker Desktop for Windows, Docker Desktop on your Mac. You can run them on pretty much any platform that you can think of once you get them into a container. So some of the big challenges of the microservice architecture is distributed transactions. So the idea of an ACID transaction, you'll have to think about that as you're designing different services. Because if you split out your services, but you really need, if a user clicks this button and tries to process this transaction, if it can only succeed if all of these other things succeed, but success means sending messages to other services and getting responses back, it can get complex as opposed to that monolith where maybe you call a method, it either returns success or fail, and then that's it. Testing the entire system as opposed to a single service. The one benefit is you get to test a single service. The one maybe downside is if you do want to regression the entire application, running all of your services with dependencies to try to get a mirror of that is challenging sometimes. Troubleshooting service faults and application failures. Certainly a big challenge with a distributed architecture. If action A kicks off 5 messages and those go to different services and you get a failure, just something isn't working, tracing all of that down to where the failure occurred and what's going on can be a challenge as well if you don't have monitoring infrastructure set up correctly. And then the inter-service communication reliability and performance. The message bus and infrastructure certainly is designed to help alleviate this using standard processes and software that's designed really with this in mind. But certainly now you are not only communicating within the context of an app, you're now sending messages across a network, which can introduce potentially some latency, but also some reliability concerns as well. It's just another factor that complicates things, but with good benefits. So specific to .NET, the microservice development challenges, what are they? So running multiple projects, Visual Studio Code, Visual Studio, they make it a little bit easier to now start up multiple projects. But still getting those things up and running takes a little bit of configuration. Service discovery. So if I've got multiple web apps, I spin those up, or I've got a front end trying to hit the web apps. I've got hard-coded URLs and app configuration files, setting up on different ports so they aren't conflicting. I got a lot of configuration that I have to do to get my development environment running, and then God help you if you've got to then change all those to get ready to go to prod or to a different environment. So the service discovery is a big challenge. And then how do you run your dependencies? So if I've got SQL Server or a Mongo or a Redis cache or something, I just spin those all up on my local machine and get my local machine set up with all of those packages so that I can actually run this application with the dependencies. It can be a challenge. So what solutions are out there already? Mainly Docker and Docker Compose. Can that be a solution for us? And yes, in many ways it can be. So it certainly solves the problem of running multiple projects, and it also solves the problem of running your dependencies. If you've got a RabbitMQ dependency or a Redis dependency or even a SQL Server dependency, those all have Docker container packages. So with Docker Compose, you can absolutely add those in and spin those up and leverage those as a dependency resource without having to configure your local machine as a dedicated Redis cluster or a SQL server, for example. The downside that I see, and that Microsoft also saw when they were putting together Project Tye, is that there's a steepish learning curve for some of the Docker and Docker Compose stuff. So before you can even get started running this, you've got to go through the trouble of learning Docker and Docker Compose and getting those files set up and understanding that environment before you can really get going. And the other thing is, maybe in development at those early stages or at the development level, you don't want to containerize everything at that point. You just want to develop and debug in Visual Studio like you're used to. So those were just some of the challenges and thought process that Microsoft had when they were developing Project Tye. So how does Project Tye help with all of these? So it has two main goals. So make development easier by running many services with one command, using your dependencies in containers, and then providing methods for easy service discovery. And then the second goal is to make deployments easier by automatically containerizing .NET applications, automatically generating Kubernetes manifests with minimal knowledge or configuration, and all of your configuration is stored in a single file. So these are the two main goals with how Project Tye is looking to help ease development in a microservice world. So some main features of Project Tye is service discovery via configuration, and we'll talk about that here in the demo and show you how that's done. It natively understands .NET project files. It has a dashboard for viewing metrics and logs and information about the services that you're running. It will run Docker dependencies. And even if it's not .NET, it understands Docker files and then can build and run other applications if you've got a Docker file already created to build that out. And then it will, as I mentioned, Dockerize. I don't know if that's a word, but it's here, so go with me. And it will also then deploy your services to Azure Kubernetes service. I believe it'll deploy to any Kubernetes cluster that your machine has access to via kubectl and the commands, but obviously it's Microsoft, so they're pushing Azure Kubernetes service. And then it also has a hot reload support for code changes. So a lot of cool features with Project Tye. So let's do a real quick, simple Project Tye demo that will walk over some of the high-level configuration and features of this. So this is our simple demo app. I like drawing this diagram because I hate diagramming things out, but this one was fun to do because it took 10 seconds. So very simple application, just a front end talking to a back end. So go ahead and I will just spin this up, and it's one command. So Tye run, and I'm going to add the watch flag to it. And so what you'll see is you'll get some messages piping in. Can everybody see this? You need me to zoom in further?
Yeah, that's pretty good.
Good deal. So you'll see you get this dashboard running at localhost port 8000. So I'll go ahead and open that up. And what you'll see is here's our Tye dashboard. So we've got two services, front end and a back end. And it has gone out and automatically created bindings for us for these projects. So you can see the front end's running here. It's got a HTTP port and an HTTPS port. Same thing with the back end. And I'll just go ahead and launch the front end. And what you'll see here is we've got just leveraging the weather forecast samples that you see if you ever spin up a MVC app or any type of app. The weather forecast is the flavor of the day for their little demo. And so this is actually, the weather is coming from the backend API. And I can prove that if I go into this, and you'll see I've got my list of conditions. I'm going to add Death Valley into here. I'm going to save this, and what you can observe here is it picked up that a file was changed, and it's going to restart that service for me automatically. So if I come back here to my front end and refresh this a few times, we should see now Death Valley is one of our summaries. So that's the front end talking to a back end with the watch functionality. Now, I want to show you one interesting thing with this. Let me go ahead. Do I want to show anything yet? No, just close it. If you look here in this directory where I'm running Tye run, I've got a folder that is my backend project, got a folder that's my front end project, and then I've got my solution file. I don't have any configuration file. I don't have anything special in here. Because these are just two .NET applications with no real special configurations, Tye can do its thing without any configuration file at all. So pretty simple if you're running just a pure .NET application like this. So one of the cool things, and I'll show you this, I mentioned the service discovery. So I'm going to go into the front end actually here. And this piece of code right here is the big thing that Tye gives us. This configuration, get service URI backend. So because my project here, the project name is backend, and because I don't have any configuration file, by default, Tye is going to create a service named backend. And then it created a service named front end, and we could see that back on the dashboard. If I run this configuration get service URI backend, it's going to get and return here that localhost port 60,000, whatever it was, and then return that. And so we can set this as the base address that I'm making my request to for that backend. And this will dynamically pick this up every time Tye starts. So with this one configuration command, it will do that service discovery and find out what URLs the backend application is running on. I will say with this, if you want to use this, the one dependency here is this Microsoft.Tye extensions configuration package. And you've got to enable preview packages because all of this is still in preview experimental mode. So I'll keep going. Does anyone have any questions here just right now about what they've seen so far? Nope. Good deal. Looks like somebody dropped something in the chat. Nice. Cool. Okay. Good.
Hey, this is Jason. And I didn't have any particular questions on the technical aspects that you have running here, but you said you've implemented this sort of structure for clients, or using Kubernetes and the Tye.
Not so Tye. The one caveat I'll say about Tye right now, and I think I should have put that in the very first slide. This is very much an experiment.
Yeah. Okay.
From Microsoft right now. It is, and they'll tell you right up front in all their documentation, presentation, all that stuff, it is not production ready.
Okay. So yeah, that's what I was wondering. I was like,
the answer is absolutely not. I have not, nor will I recommend at this time for a client to use this as their de facto standard. However, if this gets first-class support, which it looks like, and I'm hoping it does. You'll see some of the other features as I go through it. I'm really hopeful that it does, because it will make things a lot easier for some of the things that we've had to do manually to get a microservice deployment and CI/CD pipeline and all of that stuff going and getting out to Kubernetes. If Tye kind of had everything buttoned up and was production ready, man, it would take away a lot of headaches that we've had to deal with going along the way with the conventional route in that stack that I showed earlier.
Yeah. Yeah, because I can see how this would streamline the CI/CD in quite a few areas. So
absolutely, and we'll show some of that here as I get into the I guess more advanced scenario.
All right.
Speaking of more advanced scenario, let's go back to my presentation here. So I'm going to demo an application that I created called Photolye, the best place to share photos of ice cream. So this is a little diagram of all the components that are going into this demo application that I'll show. So we've got a Blazor front-end web app. That sample application that I showed before was actually just using Razor pages, and I started when I built the sample using the same thing. So it exists. I will not be showing that because the Blazor is the new hotness, so I wanted to get that working as well. We've got a couple services, so our photo service and a comment service, as well as a notification service that is managing our SignalR connections. Those are all .NET Core projects. Then we've got a photo processing service, and this is in Python. So got different languages going around here. It's all using a MongoDB database. And then there's a RabbitMQ message bus that is supporting communication between these services and kicking off different events. And so as I go ahead and deploy this and go into some more details and show you some things, this will kind of make sense of where this is all going. So let me go ahead and spin that solution up. And I'm not going to change any code, but I'm still going to throw the watch flag on it just for fun. So what you'll see as this comes up is it starts our dashboard, but then it's going to start going through and building up our processes. And once this gets up, I'll go to the dashboard and refresh this. And you'll start to see here are all of the services that are coming up. Let me make sure that we're all started. Moving to ready, moving to ready. Okay, so we should be in pretty good shape. So we see I've got now a lot of services. And some of these, as I mentioned, the comment service, photo service, and this notification service are all .NET Core projects. My photo processor here is, you'll see, it's a container. So by default, Tye does not know how to containerize a Python application. But I've created a Docker file that I've defined myself of how I want that Python application containerized. And it will tell Tye what that Docker file is, and it goes ahead and happily creates it, builds it, and runs it. And actually for this one, I've spun up 3 instances of it. I've got my 2 front ends. We'll focus on the front end Blazor application. Then I've got Mongo and RabbitMQ. You'll see these are also containers because these are third-party dependencies. So I've just told it, give me Mongo from Docker Hub and give me RabbitMQ from Docker Hub. And it spun those up as part of the list of services here. And then finally, there's this ingress controller, and we'll talk about that in a little bit. If you are at all familiar with Kubernetes, the ingress is the external facing network level layer 7 load balancer that can route traffic in from the outside and get traffic to your different services running inside the cluster. So if I go to front end Blazor here, see this spins up, and I've got the similar diagram here, and then I've got some just animations of kind of what happens when you kick off one of the functions of the application. So this is just a GET request, which is actually going to go to two separate services to get both comments and photos. Uploading a photo, so we upload that, but once it gets uploaded, we'll kick off some messaging infrastructure to tell the photo processing service, hey, there's a new photo to process. Once that's done, we then tell the notification service, hey, this photo has been uploaded and it's done processing. And then finally on the comments, I make a comment that only goes to the one service, but then it kicks off a message, and anyone else that's viewing that same photo at that time, their comments will update in real time. So all of these services are communicating together. So let me go ahead and just demo this here locally. And let's see, let's just pick cookie dough ice cream. So we'll upload this. So the photo's been uploaded. It has now sent a message to the photo processor. It's spinning there processing this photo. And as soon as it's done, it sends a message back through RabbitMQ that, hey, this photo is done uploading. I get a message back in my Blazor app to refresh this page now that the photo has been resized and sharpened, and now it's available to comment on. If I open up another window here, you can see some of that SignalR communication happening. If I split my screen here. All right, there we go. So I'm going to go back to my photo gallery. On this side, I'm going to go ahead and just add a new photo. Let's do this one more. So new photo uploaded. Got a message here on this other user watching it that, hey, a new photo's been uploaded. Do you want to refresh your gallery? So yeah, I'll refresh, and now I see my new photo. If I open this guy, I commented on this side immediately through that SignalR communication. It notified this window that a new comment was added. So you get real-time communication between these. So all well and good. Let's take a look at how this is actually accomplished in a little bit more detail. So you see, this is a lot more complex. So this is where you'll have a Tye.yaml file. And so this is what you need to create, or what you can use Tye init to create, and it will create a baseline version of it. But this is what was created in the sample project, was just defaulting to some services. But now, since I've got this more complex, I've got to tell it what are my services, excuse me, and how do I want them to run. So for example, under this services tag, I've got my comment service API. And I've referenced that as a project because this is just a .NET Core project. So that's all I have to tell it. It knows how to build this into a container, how to deploy it, how to run it, because it's just a .NET project. It knows that natively. And by default, without passing it anything else, it's going to create an HTTP and an HTTPS binding for this. If I go back to the dashboard, you'll see my comment service has got 2 bindings. Going down the list, the photo service API, again, just a .NET project, but I'm using a couple other features that I won't go into, but I was playing around with. If you're familiar with liveness test and readiness test, it can poll the application on 2 different endpoints. One to check, is it up? And the other, you can put some logic in there to say, hey, can I connect to my database and my dependencies? So one of these, it will say, yep, the application is alive, but if it's not ready, I'm not going to route traffic to it. So that's just using a liveliness and readiness feature of Tye that is kind of common in a Kubernetes world, but you can configure that right through your Tye YAML. My notification service, another just .NET Core project, so I just reference it via project. But this one, I'm going to override the bindings and just tell it I only want HTTP and I always want it on this port. So you can override that. Next one down here is that photo processor, the Python application. So again, not a .NET project, but I'm telling it here, run this Docker file with this context. I can also pass in a replica count. So in this case, I'm spinning up 3. And then I can also pass in specific environment variables to this Docker container to give me things for example, my RabbitMQ username and password, super secure. And then I've got a delay time set in there to make the demo work a little bit better. But so pass in environment variables and set up different things on those containers that is needed. Then the front end, the Razor Pages project was just another .NET project. The Blazor project, again, another .NET project. I'm overriding some bindings, and then I'm passing in some environment variables to that. And then we've got our Mongo and RabbitMQ. So I've given this just an image name. And so by default, if I just tell it Mongo, it's going to go out to Docker Hub and try to pull down the Docker image with this name. So this is going to get the latest instance of the Mongo container that's been published. It requires a couple environment variables to get spun up there. And then in the binding section, I'm going to define a port, but I'm also going to define a connection string to Mongo. You'll see that in a second. In addition, if you're familiar with containers, by default, the container, if I spun this Mongo instance up, all the data that I put into it would persist as long as the container was alive. But Tye also supports volumes, and so you can map that container data to something on your PC so that it persists. And then RabbitMQ, very similar, pulling an image, passing in some environment variables. And then for this image, it actually spins up and listens on 2 different ports. So I can set up those bindings as well and give it protocol, port names, and then give it a unique name per binding. And finally, I mentioned the ingress controller. So ingress is that level 7 load balancer that is going to route traffic in. I've set this up with a binding on port 8080 HTTP, and then I've got these rules. So if I hit localhost 8080 with this path, it's going to route that traffic to the photo service API. Similar to the comments, if it sees this path, it's going to route that traffic to the comment service API. With this Photolye hub, it's going to route that to the notification service API. And then for everything else, it's going to route that traffic to the front end Blazor application. So just see my normal web app, my single page application. So that's kind of at a high level, some of the features. Probably went into too much detail there. All of this, and there'll be links at the end of the presentation to get to the GitHub repo for Tye. They've got a schema definition. Do I have this? Yeah, so this page here, the Tye YAML schema, will show you all of the information about setting these things up and the things that I haven't touched in here. So that's the application. That's how it's spun up. I will show you this as part of the service discovery. If I look at the logs here, what you can see here is this is the actual Docker run command that Tye is running. And so you see all of these environment variables. What Tye is doing when you create those bindings, it's setting up environment variables that define those bindings and then passing those in every time it runs a container. So for example, this notification service API, HTTP service protocol, HTTP, port number, all these 5s. There's a connection string somewhere down here for Mongo. If I can find it, here it is. So connection strings Mongo. So that's how it's doing service discovery between containers, is it's telling every container via environment variables what else is running in the system. And so under the hood, what's happening when you do something like this, configuration get service URI backend, it knows that, all right, given this name, the service URI is going to be a combination of environment variables that will define that are running inside my context or inside my Docker instance. So that's all it's doing, is it's given this, it's just reading the right environment variables to get this information dynamically. Cool. So now let's talk deployment. I won't bump that up. Yeah, well, here, because I've got another slide on it. So we've got all this running locally, right? The next big thing that they were trying to make easier was deployment. So deploy to a Kubernetes hosting environment. So there's a 5-step process here for how it gets out there. So the first step is it's going to determine which projects are local development projects versus those dependency projects. And then for those dependency projects, it's actually going to prompt for connection string information. Tye does not deploy those dependencies. The idea being that if you're referencing a RabbitMQ instance or a Mongo instance or a SQL Server instance, you've already got that out there and created. You just want your services to be able to connect to it and leverage it. So at deployment time, it will realize, hey, this was a dependency used locally, but now in the deployment, I'm going to prompt you for a connection string to connect to something that already exists. Then for each of your projects, it's going to create Docker container images, and then it's going to push those to a container registry. Finally, once it's got those pushed out, it's going to create a Kubernetes manifest file that then deploys the pods services to the Kubernetes cluster. And finally, it will take that ingress and deploy that as an ingress controller out to a Kubernetes cluster to have everything up and running. So I will show you that now. I've already got a container registry. I've already got a Kubernetes cluster up and running. You'll see, I'll go ahead and kill this. This will shut down. I can just get this one now. If I do you'll see I've already deployed my dependencies, Mongo and RabbitMQ. But other than that, I don't have anything out here. So I'm going to change one thing in my Tye.yaml file. I'll talk about why here on one of the closing slides. So I'm just going to change that environment variable. And then I'm just going to do a Tye deploy, and I'm going to do it in interactive mode. If I don't do it in interactive mode, it's going to realize that I don't have connection strings for those dependencies, and it'll say you need to run in interactive mode so you can give them to me. So I'll go ahead and do a Tye deploy. And this will take just a couple minutes, but you'll see it'll start up with that Comet Service API, publishing the project, building a Docker image, created the Docker image, pushing that Docker image. And once this gets pushed out, and this first one always takes a little bit longer because they're all based off of the same images. So once this first image gets out, a lot of that other stuff is cached for these pushes out to my container registry. And you can see I've got this is my container registry out here, just using an Azure container registry that I defined in my Tye YAML file. In interactive mode, if you haven't already defined one, it'll ask you where you want to put it. And you can send it to any Docker repository, AWS, Docker Hub, wherever you want. I just happen to be using an Azure container registry here. So what you see here is, all right, I've realized that my comment service relies on Mongo, and you'll see it also relies on RabbitMQ, but it's prompting me for the connection string for Mongo. So this is where My live typing better be good, otherwise the demo is going to fall flat. All right, referencing. All right, looks good. All right, so now it's going to ask me, give me the UI to use for the service RabbitMQ. Okay. And then I mentioned that RabbitMQ actually listens on 2 different ports. So it's going to say, give me the second connection string for that other one. And this one is just cool, done. You'll notice here, and this is one gripe that I have, it prompted you, enter the URI for service RabbitMQ. And it created this one, and this RMQ is the unique name in the Tye YAML file. But again, this enter URI for service RabbitMQ, it doesn't tell you which one it's asking for. So you just got to know it's going to go down in order. I wish that was an enhancement that when it prompted you to enter a connection string, it told you what the name of the binding was when you got prompted. It'll show you what Kubernetes secret it created, but obviously at the time of binding, you're kind of guessing. So here we go. So now it's going through the Photoservice API, another .NET project, building that Docker image, pushing it, notification service, building, pushing, the photo processor, that Python application, building that Docker image, pushing it out there, the front end application, building, pushing, Blazor application, building that, pushing that out. If I go and refresh my list here, as these are coming in, you can see these containers are getting added to my Azure container registry. So Docker, Blazor is taking a second. There we go. All right. So now it's going to deploy my ingress controller, the Photolye ingress. And this is another, I guess, gripe or thing that's going on with Tye, just because it is an experiment. The ingress by default is deploying some old versions of these ingress controller definitions. So they still work, but they need to update Tye to update the ingress definition that they're pushing. So all right, so now it's done. It's all out there. They tell you, here's your ingress IP address. And so if I do a kube git deployments, here's all of my deployments. You'll see I've got everything up and running. I've got 3 instances of that photo processor, just like I asked for in Tye.yaml. Here's all my pods. They're up and running. Here's my services. And here's my ingress controller that's up and running. So what I've done is, this has got anyone right now watching this could hit this IP address and get to this application. This ingress controller has opened up, has created a public IP that is now open on port 80, and anyone can get to it. I've actually just edited my host file. Yeah, it still matches, good, so that I can hit this via the domain name. So if I go back out here, let me open up this guy. We'll just. So Project Tye Kubernetes with nothing after it. That ingress controller is going to route that traffic to my Blazor application. I go to my photo gallery. On the back end, Blazor is making a request to /API/photo gallery. Ingress is routing that to the right service, allowing me to go ahead and upload photos. Photo processor is picking it up, running with it. When it's done, SignalR will pick it up and pop up. And again, I could demo the same thing again with a different window of it all running. But this is now, obviously this URL isn't working, but if somebody hit the IP address, you could get to this pretty easily because it's now all public. And then Tye's got another feature of Tye undeploy. So if I go ahead and run that, it's going to go ahead and load up the application details, and now it's just going to go ahead and delete everything that was deployed. So what you'll see here is all of my pods are terminating, except for Mongo and RabbitMQ, which were the dependencies that were out there beforehand. So if I come back to the presentation here for the last few slides of wrap up, just talk about some of the current limitations and issues. So should have mentioned this up front, but thank you for the question. It is still very much an experiment, not production ready, and they'll even tell you that. One of the things and some of the reasons I was changing those environment variables around is that the local ingress that gets spun up, does not support WebSockets. So that change in environment variable that I did flipped some things around so that it would use ingress when it went to Kubernetes, but would not use ingress when it was running locally, because otherwise the SignalR connections would not work. So they spin up a local proxy that mimics an ingress, but it doesn't actually have all of the features of the one that gets spun up in Kubernetes. There's some configuration options not available in Tye YAML yet for Kubernetes. So as they build that out, you can maybe Tye.yaml becomes the de facto single file standard, but until then, you're still going to have to manage configuration in Tye YAML and Kubernetes configuration files. That Blazor, WebAssembly, and other single page applications, even if you do like an Angular application through .NET, it's not going to know how to build that and containerize that by default. So actually, behind the scenes for Blazor, running locally, it runs just fine. When you put it into a container and try to publish it, it doesn't. So you have to define your own Docker file that tells it, hey, here's how when you deploy it, I want you to host it in this way so that it actually works. The other challenges are service discovery with those SPA platforms, because with the nature of a SPA, right, it's my machine making a request to a service, not a service making a request to another service. So how do those JavaScript files or files that get deployed or run on my local machine service discover the API calls out? And so that's through ingress is basically how you have to manage that. And then I mentioned the default containerization is broken or not implemented. They're looking at that. They're trying to get feedback on what languages, what things to support, to give first-class support on. But right now, those single-page applications, you got to do some workarounds to get those going. I mentioned the prompts for the binding configuration settings can be a little unclear. And then the other thing I've noted here is it's as designed that the dependencies are not deployed at all. But in some cases, maybe with this application, I've got a Redis cache that I want running in Kubernetes, and it's tied to this application. And I want that deployed and undeployed and bundled up with my app. Maybe the option to have that dependency managed through a Tye.yaml could be nice. And then finally, some other features that it has that I haven't touched on today, and some future enhancements that they're discussing. Support for Dapper, which there's Dapper ORM, which is a database object relational mapper, and then but that's got two P's and an E, I think, in there. But DAPR is Distributed Application Runtime. It's a system that will run sidecar containers next to your services and provide a lot of functionality that we usually implement with microservice architecture. I'll be honest, that is the elevator pitch that I've read from their site. I have yet to experiment or play with it, but it's definitely on my list to learn what features and functionality this provides. Tye also has diagnostics with Zipkin, Seek, Elasticstack, so they plug in with some third-party tools that can help you monitor and log within your application. Azure Function support. So Tye, if you're developing an Azure function or you've got a service that then calls out to an Azure function, Tye, if you're developing that locally, Tye can spin up that Azure function as well as part of these other services, and then your services can call that function running locally. Tye will not deploy functions currently, but if you've got an Azure function that is part of your service workflow, Tye can manage that, at least for local development. Some things they're looking into, the multi-repo scenarios. So you can, if you've got multiple repositories, you can have a Tye YAML file reference different projects and different folders just by providing the right path. But what they're looking into with this is, let's say you've got two separate teams working on a different microservice application. And so this team puts together a Tye.yaml file that defines all of their services, and their application is up and running. If I've got a team working on something that maybe needs to leverage that, can I just import or use their Tye.yaml file and have my Tye.yaml reference another Tye.yaml and spin something up that I don't need to know anything about? So they're looking at that, the multi-team, multi-repo scenarios. And then two other commands that are kind of embedded and run with that Tye deploy, but Tye build and Tye push. As of the last video and documentation that I saw from Microsoft, they were talking about the CI/CD pipelines. And a lot of times right now, if you're in Kubernetes, you already have deployment pipelines to get stuff to your Kubernetes cluster and set up things that maybe Tye can't manage right now, certain ingress configurations, different security secrets, things like that. But what you could do is, because of that default ability to containerize .NET applications, part of your CI workflow could be using Tye to build and push those images to the registry without having then to code your own Docker files for some of these things that Tye can manage automatically. Again, that's kind of future looking as to how it could play. Right now being a experiment, probably get familiar with it, but probably would not push this on a client right now unless they are really gung-ho and have a high tolerance for some risk. And so just finally, some resources. The main Project Tye repo is here at .NET/Tye, Tye documentation in this README. This video, if you watch this video, you'll see a lot of similarities between this video and my presentation. This was definitely an inspiration for me to start diving into this. So took a lot of the insight that those guys have for who are developing it, for where it can be used. And then actually that Photolye application, that whole application source code is hosted on my GitHub repository. So if you wanted to spin this up and run it and see how all this goes, it's all out there and available, and you probably could have saved some time on this presentation because you can do it all your own. But hopefully this was helpful, give you an overview, showed you something interesting, some of the new, I guess, again, I use the word experiment that Microsoft's working on and where they're trying to improve the process of developing microservices in a .NET world. So I hope that was informative. I'll go ahead and wrap it up there. Any questions, anything else anybody wants to see? I know we have some time left, but I know I've been on plenty of these that go way too long, and I didn't want to be that guy. So again, thanks for participating. If there are any questions, fire away.
Do you know how long they usually keep those kind of in the public preview until they release it to general availability? I notice this has been out there since what, May of last year?
This is an interesting one, in that I haven't seen anything. So .NET 5 is out now. .NET 6 is the LTS release coming later this year. I was hopeful for some information that Project Tye would be released as part of .NET 6 as a first-class tool or that be production ready. I have not seen anything like that. I really have no read on what the life cycle of this is going to be. I know they are on, if I go back to the GitHub repo, I know they're on 0.6. They were on a cadence of about, I guess it was longer than that. So 5 came out in late November of last year. 6 came out in January. So I'm hoping that a 0.7 is out soon. I think they were trying every 4 weeks is what they put it out. Obviously, it's slipping on some of them. But certainly you see some, the length of issues, pull requests that are getting submitted, discussions around this. There's a lot of interest and interaction around this project or this tool. So I'm hopeful that the Microsoft team keeps pushing it and moves it down the pipeline into something that is GA.
I could probably
But
make
I don't have a timeline.
a bit of a comment on that. From what I understand and have heard, they've had other priorities in the last few months, and so that's why development has slowed down a bit. But Glenn Condren, who's the program manager on the team, has indicated he should be making an announcement fairly soon on the progress and the state of the project and whether or not it's going to potentially make the .NET 6 release.
Gotcha. Well, you're more tuned into that than I am then. But that's really good. Yeah, I hadn't seen anything public, but that's great if you're following communications from him through those channels and are able to share that. Thanks, Stuart.
Yep.
Have any other questions?
There's one in the chat. There's one on the chat.
Laura. That is a missed opportunity. Dang.
It's a good name though. And
That's a good name.
Tye undeploy was just like a rollback route, right? Like if there were problems with the deploy, you just wanted to kind of cancel what was deployed.
Yes and no. Yes, in that it rolled everything back. The no is, let's say you're on version 1 and you did a Tye deploy and then you did a Tye deploy again with like some updates. If you do a Tye undeploy, it's not going to roll back to version 1. It's just going to destroy everything that was deployed. So not exactly a rollback. One thing I will call out is I was seeing this when I was doing some development. When I spun up those dependencies, I've got just a Kubernetes manifest here that I ran to deploy RabbitMQ and Mongo. So there's a label here that is app.kubernetes.io part of, and I've named this Photolye dependencies. Previously, I was naming this Photolye. I was like, oh, it's all part of the application. It's all part of Photolye. That's also the application here. So one of the frustrating things that I ran into was that I was doing the Tye deploy and everything would go out exactly as expected, except for RabbitMQ and Mongo, exactly as they say. But then when I would do a Tye undeploy, it would destroy RabbitMQ and Mongo, even though it never deployed them. And so I thought that was a bug, that they were just basically destroying everything. But it looks like they are referencing this part of label. So Tye will create this and set this to whatever your name is here. And then when you do a Tye undeploy, it will uninstall anything with that label. So if you've got your dependencies deployed with this label on them, it will destroy your dependencies. So I tacked on -dependencies, so it is not picked up by the Tye undeploy command and destroyed when I go ahead and actually try to uninstall the stuff that Tye is able to manage. So just a little into the weeds there on that, but yeah, things like Helm and Helm charts, which is probably another discussion for a whole nother presentation. Helm deployments do track versionings or versions, and you can, if you're all of a sudden get yourself into a bad state, you can do Helm rollback to a specific version, and it will actually then roll back the deployment to the version of the images, the version of configurations, environment variables that were of the state you want to roll back to. But Tye undeploy, to my knowledge, will just blow away anything that matches this label for the Tye YAML in the directory that you're running that for.
Well, that sounds safe.
For sure.
But very cool. Yeah, I like it.
Yeah, which is where I think where they were at now in their discussions of, if you want to use this today, maybe leverage the capabilities of building and pushing the containers, but leverage an existing Helm chart pipeline or other deployment pipeline that you've got to actually manage the deployment to Kubernetes. Even though this offers that feature to make it super easy, that's one thing, and one of the bugs that, or one of the, I guess, lack of features that you just mentioned, that would keep this from being, I guess, safe for a production ready environment.
Yeah, that would seem to me a big hole, because part of managing and distributing these services through an automated process is the efficiency in being able to redact those processes and services. So I think without that, key capability, or without, being able to quickly put that in place, that would definitely keep this on the drawing board.
Yeah.
Not in
and I don't know, I haven't fully dove into like all the CI/CD pipelines and ramifications of this. Maybe a solution is with your tagging. You just never do an undeploy, always a deploy, and you version your Tye YAML file, right? So, oh darn, version 1.3 is bad. Let's do a Tye deploy with the Tye YAML file that is references our services at 1.2 version.
I immediately thought
certainly things.
I immediately thought of, as you were saying that, different ways you could, actually take advantage of that labeling. But I mean, that's changing probably a pre-existing process and managing your systems and versions and stuff like that to accommodate for a gap, and that's a pretty big change. So, yeah.
Yeah, absolutely. I will say, for local development, this has been, it's been awesome. I mean, this application is pretty complex, but I mean, it didn't take me much to put this together and have all these services communicating and flying back and forth, and being able to spin them all up with that one command and have a dashboard to view logs and see what's going on has been really, really nice. One of the features I probably should have demoed, but it's just debugging. So as you're running this, you've got a couple options. You can attach your debugger to any of these running processes and then breakpoint and do anything just like you would normally. One of the other things is, as you start this up, you can actually give it the Tye run command, provide that with a debug argument, and either tell it all services or one specific service, and then it will actually wait for a debugger to attach before starting it up. So you can capture, if you've got something like in your startup CS or something like that you want to capture on startup, that you would miss if you just let it start the container. You can tell it, hey, for this service, wait till something attaches and then fire it up and hit any breakpoints that show up in there. So certainly debugging and doing this stuff locally is very, very easy, and this makes it nice. Some of the deployment stuff, yeah, definitely. There's probably pre-existing pipelines that are probably your best solution right now until this gets some of those issues we discussed get figured out.
Yeah, that but I can totally see. I mean, it's definitely has an advantage. I mean, working with the more complex systems and in the larger microservice structures, having that visibility and that speed to be able to swiftly put that stuff out there, definitely be nice. But yeah,
Absolutely. Yeah, the biggest thing for me is just the automatic Docker file creation for these .NET projects.
Mhm.
I mean, in the project we were at, the nice thing is once you get one Docker file built that works for your .NET Core project, you kind of rinse and repeat and create new ones. But this, you completely eliminate that. If it's one of these languages or solution or project types that it understands, which is the .NET Core Web API projects, it'll handle all the Docker creation for you, which is kind of nice without ever writing a Docker file. So
yeah, I was curious. The natively what it supports. I mean, is it a good chunk of the Microsoft languages? The various pieces that it supports natively, or is there?
yeah, it's pretty much any of the standard
Okay.
project types, but then you do run. So I mean, the .NET front end, like a Razor Pages application, was their demo app. It was able to containerize that and host it perfectly. Your .NET Core Web API MVC projects able to containerize it, run it perfectly. As I mentioned, the Blazor WebAssembly, it was able to run it locally and everything looked fine. But as soon as I went to deploy it, it would not run. It was saying, what the heck are you trying to do? And so I had to, and I can show that, create a Docker file that actually just tells it that as you build the project, run it in an Nginx web browser or web server. So I mean, really, the Docker file is stupid simple. And if you pull down this code, I've actually got a link to one of the issue where this is raised, and they've raised this issue, and this in that same issue thread is where I found the demo code of, hey, here's how I'm handling it. So yeah. I sampled that, let's say, and it works fine. But some of those things that I mentioned, like the single page applications, some of the things, just the first party or first class support for them, you can absolutely make them work. There's just a little bit of extra effort and tuning you have to do versus it handling it out of the box natively.
Very cool, John. Thank you. It was pretty cool demo, and enjoyed seeing that.
Good deal.
Yeah, so wrap up there. Thank you all for coming this month. Like I said, I'll get the new sessions up over the weekend, and please feel free to join us in April and beyond. Outside of that, as soon as John gets me the slide deck, I will post it up to Meetup so you all can download it and play with this yourself and take it on. And it just occurred to me, I totally forgot to post Harold's video from last month. So I will get that up as well as John's video from this month. So feel free to poke me in the side if I don't do stuff that I told you that I would do. So I'm happy to take that on. So anyways, I hope everybody has a good end of the week, and see you all here next month. All right. Thank you.
Awesome. Thanks a lot, everybody.
Thanks again, John.